In this video, we'll discuss sales tax. Now, a sales tax is a tax that we add on to the end of a sale on a good or a service. In Virginia, we have a state sales tax of 5.3%. Now, there are also things like meal taxes, which are additional taxes added on to the end of a sale on prepared meals at bars and restaurants. In Radford, that's 5.5%. So that means if you actually get your final bill, what you're paying is not 5.5%, but it's the 5.3% for Virginia sales tax and the 5.5% for the meals tax. So you end up paying a total sales tax of 10.8%. Now, when you have to calculate such problems, taxes are just a type of markup problem. What we do is we're going to start with the final price equaling the retail price plus the tax times the retail price, just like other markup problems we've done before. We could also use our proportional reasoning method, where we know that final price over the retail price will equal the percent out of 100. The key to remember is that if you use the proportional reasoning, that percent is the percent plus the tax percent, because that final amount compared to the retail, it's more than 100% of the retail price. So if we're talking about like the 5.3% of Virginia sales tax, that means we would plug up in the percent column 105.3%. Or if we were talking about Radford's meal tax, that total percent would be 110.8%. So let's look at some examples. Say the retail price for a bottle of shampoo is $4.75. If we have a sales tax of 5.3%, what is the final price? Make sure to round to the nearest cent or the nearest hundredth place. So we start with this first option. Final price should equal the retail plus the tax times the retail. Do we know our final price? No, that's what we're trying to find. Do we know our retail price? It says the retail price is $4.75. So I can substitute in for retail price here and here. Do I know my tax percent? Yes, it's right here. So I can substitute that in, and now I can solve my equation for the final price. Now remember, I can't deal with this as a percent. I need to change it to its decimal. So I divide by 100 to get 53 thousandths. And that's okay that it goes beyond hundredths because it has this decimal in the percent. Now I multiply 53 thousandths by $4.75, and I add my two values together, and that's going to give me $5 and then 175 hundred thousandths. That's well beyond the cent. So I need to make sure I round now to the nearest penny or the nearest hundredth. So I underline to help me remember where I am, and I always look one place value to the right. And I say, is that 5 or greater or less than 5? 1 is less than 5, so I do not round. I maintain this at $5. So I would say the final price for my bottle of shampoo is $5. Now, what if I wanted to use the proportional reasoning method? It's still going to use the same information and will come out in the same way. So the new price is always going to represent the final taxed price. We don't know that. The original price is what was the initial retail price of the bottle. So that was $4.75. My percent, remember, is not just the 5.3%, but it's 100 plus the 5.3%, because this is 105.3% of 475. This value should always be greater if I'm adding on the tax. So now to solve this proportional reasoning problem, I can cross multiply, or I can multiply both sides by $4.75. That simplifies to 1 on the left side, and then I know that the 105.3% divided by 100% will give me 1 and 53 thousandths. So if I look, I'm back in the same place. Here, 1 plus 53 thousandths gives me the 1 and 53 thousandths. So I'm in the same problem. It's just a matter of which method makes more sense to me when I'm solving problems. Let's look at one more example. Say a group went out to dinner and their meals cost them $86 before tax, and their total tax was 10.8%. What will be the price of the meal? So again, we can start with the same formula. We do not know the final price. We know the retail price was the initial cost, which was $86. So I'll plug in 86 and 86. and my tax percent was the 10.8%. Now I can solve and simplify. I can't deal with 10.8%, so I need to change that to its decimal. So I divide by 100, and that's 108 thousandths. I multiply that by $86, and then this allows me to add my two numbers to get to $95 and 288 thousandths. Again, I don't have thousands in money, I round to the nearest hundredth. So I'll underline that first 8. Then I'll look to the right, one decimal or one place value, and say that is an 8. That means I round up. So the final cost will actually be $95.29 for the meal. Now what if I wanted to use the proportional reasoning? It's going to follow the same method. The new price again is going to be the final tax price, which we do not know. The original price is what do we initially pay for the food, which is the $86. And the percent is not just the 10.8%, but it's 100 plus the 10.8%. Because again, my final cost has to be more than the cost of the initial meal. So now I can either cross multiply or I can multiply both sides by $86. This would simplify my left side to 1. And again, 110 and 8 tenths divided by 100 gives me the 1 and 108 thousandths. I'm back to the same problem. Again, I'll get to $95 and the 288 thousandths, which simplifies to $95.29. So use the method that makes the most sense to you as you solve these problems.